Good morning, everyone. We're going to continue our discussion of plant nutrition. Now, you remember the nutrients that a plant needs. They need hydrogen, they need oxygen, and they need carbon. They get hydrogen from water, they get oxygen and carbon from the air. Those are not minerals that the plant needs. And then they need a bunch of minerals. They needed macronutrients in large amounts, and they needed micronutrients in small amounts. And you remember there were a bunch of different macro and micronutrients. The three big primary macronutrients: nitrogen, phosphorus, and potassium. And then there were a bunch of micronutrients, things like nickel and zinc and iron. And so what we're going to talk about today is if a plant doesn't have those, how can we give them to them? If they don't have enough of them, what can we do to add those nutrients to the plant? So if you remember, if we finished our discussion on the macro and micronutrients, a lot of the deficiencies, if a plant didn't have enough of a macro or a micronutrient, a lot of the deficiencies looked a lot the same. They would get yellowing of the leaves, or they would get necrotic tissue. Remember, necrotic tissue means that that leaf is dying, it's turning brown, and yellowing of the leaves, remember the fancy name for that was chlorosis. Well, if it's not growing well, how do you know what it needs? Well, we talked last time, I want to continue on that talk. You can do a soil test. If you test the soil itself, send off a sample of soil that the plant is growing into a lab, it can determine how much nutrients are in that soil, how much organic material is in the soil, what is the pH of the soil, and can provide for you some recommendations for what kind of fertilizers to apply. But remember that soil pH has an impact on how well the nutrients in the soil can get to the plant, because there could be nutrients in the soil, but the plant can't get them because of the pH level. Remember that diagram we had on our last unit on soils that, say for example, iron. At low pH, iron isn't or is available, but as the pH gets higher, it's not available. So remember that kind of thing. So what's a better idea to find out how much nutrients are in the plant? Well, even better than the soil is to test the plant itself. You can do a leaf test, a leaf tissue analysis. Take a piece of leaf, send it off to a lab, and the lab can determine what nutrients are in that leaf and how much. The age of the leaf matters. So you need to know if the nutrient is mobile or not mobile. If the nutrient is mobile and it easily moves around the plant, it'll move from old tissue to new growth, from old leaves to new leaves, and to help those new leaves grow. And the old leaves will show promise, or problems, not promise, will show problems of chlorosis or maybe necrotic tissue. If the nutrient is immobile, it doesn't move once it gets in the plant. It will stay in old growth and not go to the new growth, and then the new growth will have the issues. So you need to know what you're looking for, and perhaps maybe you send in old leaves and new leaves, depending on what you're looking for. It's critical for crops. Farmers do this all the time. If they're starting to have problems with growth, they'll send a leaf into a lab for analysis. It can provide more exact fertilizer application recommendations. So if you need fertilizers, guys, are nutrients. Fertilizers have nutrients in them for plant growth. So if you need fertilizers, what kind of things can you do? Well, first off, I want to talk about the nutrient cycle, and then we'll get to those fertilizers. So the nutrient cycle, nutrients do not stay in just one place. So think about this. Roots take in water from the soil, and in that water are nutrients that have dissolved into that water. They're soluble in the water, and so the plant takes in that water and takes the nutrients in with it and uses those nutrients in the plant to grow, so the nutrients become part of the plant. When that part of the plant dies, that part of the plant then starts to decompose. If it's a leaf falling off of a tree, that leaf will rot, and it will become part of the soil again and return those nutrients back to the soil, and then another plant will come along and take the nutrients back out, and so on. So the nutrients are constantly in a cycle. But if there's not enough, we have to add some more nutrients to the soil so the plant can take it in. So the first thing we can do is we could add inorganic fertilizers. Inorganic fertilizers are made of materials other than plants and animals that contain a nutrient that the plant can use. Lots of times these come from rock that have phosphorus in it or has potassium in it or some of the other nutrients. A complete fertilizer is called complete fertilizer because it contains nitrogen, phosphorus, and potassium. Remember, those are the three macronutrients the plant needs the most of. An incomplete fertilizer is missing at least one of the three. It might be missing two of the three, but it's missing at least one of the three. And inorganic fertilizers can come in solid forms. They can come in liquid forms. The typical solid form, like this fertilizer in the bag right here, is in little pellets. And look, it says it contains nitrogen, phosphorus, and potash, which is a form of potassium, for three-way feeding. So this is a complete fertilizer. And these numbers, 12, 12, 12, it tells you how much of a percent of each of those three main ingredients, nitrogen for the first one, phosphorus for the second one, potassium for the third, that fertilizer has. And this is a solid. Now here's a liquid fertilizer. This one happens to be an incomplete fertilizer. It says it is a liquid potassium solution, and the numbers are 0, 0, 25. That means it contains 0% nitrogen, 0% phosphorus, and 25% potassium. Okay, so this is an incomplete fertilizer. This one is a complete. These are inorganic fertilizers. Don't come from plants and animals. So let's talk a little bit more about those numbers on the front of the bag. The ratios. It's the proportion of nitrogen, how much nitrogen to how much phosphorus to how much potassium, phosphate or phosphorus, same thing. So those numbers represent NPK. So for example, 10, 10, 10 means 10% nitrogen, 10% phosphorus, 10% potassium. 12, 6, 24 would mean 12% nitrogen, 6% phosphorus, 4% potassium. So that's what those numbers mean. Now, let's do a calculation. Those numbers mean how much of that fertilizer is in the bag. So if we have a 100-pound bag of 10, 5, 20, how much fertilizer is actually in that bag? How much of each of those nutrients is actually in that bag? So for nitrogen, if there's a 100-pound bag and 10% is nitrogen, 100 times 10% tells us 10 pounds is nitrogen. The second number says 5, that's phosphorus. 100 pounds times 5% gives us 5 pounds of phosphorus. And the potassium is 20, and that means 100 pounds times 20% is 20 pounds. Now this is a 100-pound bag, but it only has 20, 25, 35 pounds of actual nitrogen, phosphorus, and potassium. Well, what's the other 65 pounds in the bag? Well, two places. One, there's micronutrients in there too, but they're a very, very, very small amount because the plant doesn't need much of those. Most of the rest of the bag is just, called inert filler. It's stuff like pieces of clay or pieces of sand that are just fillers in the bag, because here's why. If I have just 10 pounds of nitrogen, for example, and I want to spread it over a large area, I'm just giving a little tiny amount to each area. It makes it very hard to spread efficiently. So we put it with something else to kind of make that whole piece easier to spread. Okay, so we'll stop on that. That's inorganic fertilizers. They can be liquids, they can be solids, but they always will have three numbers: nitrogen, phosphorus, potassium. Three numbers will tell you what percent of each one of those three is in that fertilizer. And then you can look at the label more closely and you can see percents of other secondary macronutrients, like, for example, like phosphorus or magnesium
Or you can also see the amounts of all the micronutrients in there too. But those three numbers, nitrogen, potassium, or excuse me, phosphorus, potassium. We'll talk more next time.